Welcome back, Math 098 for section 4. And when we talk about this problem, I'm going to use the letter P because a lot of students are used to using P for principal, but this is just a variable. With growth, we're going to be using this formula, R to the T power. Now, just like with the compound interest that we did, so P is the starting amount, the R is the rate as a decimal, and then T does not have to be in years. It depends on the clues, the context clues in the problem. So if it says per year, then yeah, T is in years. But if it said per month, then T would be in months. So if they ask for, 2 years, if it's 12% per month, well then you'd put 24 in the exponent. Whereas decay function, so that was for growth, I'll do decay in orange, it's really the same thing. And well, if you're decaying though, it's 1 minus, in the same argument for everything else. So it's really the same formula between the two of them. You just have to look for keywords like increasing or decreasing, growth or decay, going up, going down. And the reason why it's 1 plus, because this is going to be a short video, I do want to explain why it's 1 plus, is really what's happening is this 1 is representing the 100% of your starting amount. And then what you're doing is you're adding the percent increase. So if you think back to probably how you learned this in middle school, I'm just guessing middle school, I'm not a middle school teacher. What you learn when you did problems like this is you may have said, oh, well, to figure out the percent increase, you would do 25,000. I'm looking at this problem specifically. And you'd multiply by 0.12. And then you'd find out what that number is. I'll write that right here. And then you add that to 25,000. Well, what you're really doing is you're really factoring out at 25,000, and you're doing a lot more work. So you don't actually have to know or understand where this formula comes from, but I do expect you to use it instead of the old school method. So in this problem, we have a town of Jackson has 25,000. That's your starting amount. It's increasing, so that's why we're doing the plus. You change the rate from a percent to a decimal, so 0.12. And what you have to think about is how many years have elapsed from 2000 to 2015. Whoops, forgot to write my 5. 25,000, 1 plus 0.12 to the 15th power, because there's been 15 years that elapsed, and I expect you to use a calculator. So 25,000. And I would expect you to know that 1.12 is the same thing as 1 plus. And then to the 15th power, that means in the year 2015, if this increase continued, there would be about 136,839 people. And notice I'm rounding to the nearest whole number because we're talking about people. You don't want a decimal of a person. I wouldn't take points off if you rounded, but it doesn't make a whole lot of sense in the context of this question. Okay, let's look at the next one. You notice I don't have very many problems here because it's repeating over and over again. But if you notice in this problem, we have a tournament of 800. The number of players decreases by 30% per round. So that's why you can't really say it is the T is always in years. It depends on the problem. Find the number of players after round 9. So, we start with 800. We'd have 1 minus 0.3, because if you move that decimal over twice, it is 0.3. If it helps, do 0.30. And it is, I would say it makes sense to count the rounds out. but I'm pretty confident that it would be to the 9th power. I know sometimes these words can be confusing because it might say before round 9, and then you'd have to take it to the 8th power, even though this number is 9. But I think if we talk about after each round, then we're safe to take it to the 9th power. So using the decay formula that I had on the previous slide, I hope that all made sense. So I'm going to go to a calculator, 800. If you're not good at 1 minus 0.3, just go ahead and do it. But it is 0.7 to the 9th power. And again, I'm just going to round to the nearest whole person because it doesn't make a whole lot of sense to say 32.283 people. I'm just going to round that to 32 people. Persons, players, whatever unit you want to use is fine with me. I think you guys know me by now as well, as I don't even take points off for incorrect units. I probably should, but I don't. And then exercise 3, right before our very short assignment. Yes, they are word problems, but I feel like this is all you really need. I think that's enough. And I'm not sure how many of you are even well aware of half-life problems. But basically what it boils down to is, let me over-explain this, and then we'll get to the problem, is if we know time, and we know the amount, I'll use A for amount, at 0 years, this problem has 400 pounds of DDT. Okay, and you can pause the video and really understand this problem, but I want to keep going on. So a half-life problem means in 15 years, the DDT remaining is cut in half. That's why it's called a half-life. So half of 400 becomes 200. So if I did another 15 years from that, I'm at 30 years. Well, now there's half of the 200. And if I did another 15 years, I would have half of the 100 is 50. And another 15 years, half of that is 25. And let me scroll down for a little bit. And the reason why I'm going all the way down to 75 is now I have a rough estimate as to what my answer should be. It's somewhere between 12.5 and 25, because 72 is somewhere between 60 and 75. So it is the same formula. Okay, it's 400, 1 minus 0.5. I don't know if I need to write out that half means 50%. And 1 minus 0.5 is 0.5, so I am adding that extra step in here. But this also confuses students. Is you want to take the half-life in years, 15, and what I like to do is reduce it down to 1 year. Well, if you're going to reduce it down to 1 year, you divide by that exponent, you divide by 15, and then you want to take it to the 72 power, which is why I put the 72 in the numerator. And remember, I said my answer should be somewhere between these two values. So as I go to my calculator, 400, again, I would expect you to know that 1 minus 0.5 is 0.5. That's what makes half-life problems pretty normal. And some calculators you need parentheses, just like what I'm showing you. And I did get an answer bigger than 12.5 and smaller than 25. I'm not very familiar with the DDT, so I don't know if you can get a decimal, but according to the directions it says nearest thousandth, but I might be wrong on this. But I'm going to go ahead and round this to 14.359. You have my okay to round as the directions tell you to round. I know that I'm not very good at science, so sometimes I might give you the wrong directions. For instance, I don't know if DDT pesticide can have a decimal approximation. But anyway, go ahead and follow the directions and do the assignment. And feel free to write down any questions you have and bring them to class. But you should be good to go.